Hello everybody, can you see me? Let's see. I think it's pretty neat. Hello everybody, today we have a problem before us, a problem. And what do we do to problems? We attempt solving them. So the problem we have before us is square root of 2 is irrational. Proof. Prove that the square root of 2 is irrational. So before we get into this mathematical proof, the word irrational, from a mathematical point of view, irrational numbers are numbers that cannot be expressed as a ratio of two numbers. For example, so we have x, that if x is equal to a over b, integer a over integer b, then x is rational. But if x is not or cannot be expressed as a ratio of two numbers, it's not rational. That means it's irrational. Now we are asked to prove that the square root of 2 cannot be expressed as a ratio of two numbers. That's what we're asked to do. So let's get into the proof as fast as possible. Now, let's assume the contrary. So we're going to take a proof by contradiction approach. The proof by contradiction, we're going to assume the contrary. Let's assume that the square root of 2 is rational. So, square root of 2 is rational. That's one. And that it's been reduced to its lowest form of rationality. So let's say if it's rational, so we could just assume a over b for some a and b for some integers a and b. And this has been reduced to its lowest form of rationality. Let's say 1 over 2. So it's been reduced. That means the numerator and the denominator, they do not share any common factor. I repeat, they do not share any common factor. So let's proceed from there. Remember, the first assumption is that the square root of 2 is rational, and it's been reduced, the second one, to its lowest form of rationality. For example, 1 over 2, for example. Now, why do we take this approach? Now, the reason why we've taken this approach is, think, for example, we progress with this proof, and then we get like our final answer, or the progress we're making points to our assumption. That means square root of 2 is indeed